Hello and welcome to today's webinar. As we look out in the market today, it's clear that companies like yours are seriously investigating the challenges and opportunities that these big modules have. Today, almost all major PV manufacturers have introduced new modules above the 2-meter mark, and some with a power rating of over 600 watts. Today's webinar, titled, "Would you like to supersize that?" will attempt to provide you with the insight on this new technology and the business cases for supersizing your projects. Next slide, please. Excellent. But first, I want to share a few logistics with everyone. Thank you for joining. We really appreciate you carving this time out of your busy schedules. We are using Zoom to who aren't familiar with Zoom, which are probably few of us. There's two buttons that we want to point to, the Q&A and the chat button. If you have any technical issues, please submit those through the chat button. We have a team standing by that will assist you. And the Q&A button is for your questions. If you can submit any questions you have during the webinar, please type them in that area. And we really want to encourage your participation and send us as many questions as you can think of. We've carved out 15 or so minutes in the end to address those. And we will send out 2 polls. There'll be a little dialog box that pops up on your screen and ask you a question. And we'll share those results at the end of how the group responded. And finally, we are recording this webinar, and the final link will be emailed out to everybody who's registered today. Next slide, please. So let's get back to the program. My name, and thank you for those who are just joining, welcome. My name is Greg Shambo, and I'll be your host today. I've been working in renewable energy for over a decade. At Borrego, I am the Vice President of Business Development for Operations and Maintenance. I spend most of my time focused on executing our mission, which is solving the world's energy problems. I'm very passionate about learning and work very hard helping our customers succeed every day. I'm honored today to be hosting this webinar on this important topic. And the goal today is to help provide both the technical and business cases clarity for the use or when not to use these larger modules. Next slide, please. I'd like to introduce you to today's presenters, the experts here. First up, we have Tristan Lurico. Tristan is the head of the module business for PV Evolution Labs. He has over 15 years of solar experience. With that, Tristan is well positioned to share with us the evolution of PV modules over the years, and he will pose some critical questions for you to consider before going all in on supersizing your modules. Next, Matt Murphy. He'll be giving us a real-world view on how the numbers break down across various panel sizes and project sites and types. Matt is based out of Vermont, and he is currently the Chief Operating Officer of Greenbacker. Matt has many years of experience with optimizing cost throughout the entire solar project lifecycle. And last but not least, my boss, Aaron Hall. Aaron is the president and one of the founders at Borrego. He's been working with the leading PV manufacturer since the early 2000s. Aaron will finish today's webinar with some practical tools and tips to help you to decide if supersizing your modules will work for your projects. Next. Excellent. So before we get into the content, here's our first poll question. Which large format module sizes are you considering? So if you could please take a second, answer that. We'd really appreciate it. And again, at the end, we will display the results and share it with the group. Next slide. Great. This is where I pass the mic to Tristan. Thank you.
Thanks for kicking things off, Greg. And thank you to Borrego for inviting PVEL to discuss this hot topic today. Just a quick introduction for PVEL. We are the lab for the downstream solar market. So we define this as developers, EPCs, investors, and other project stakeholders on the buy side of the PV equipment transaction. We assist these companies, including Borrego and Greenbacker, by providing them with the technical data needed to de-risk their procurement. Of course, one of these new risks is the topic today, and that's the significant increase in module size. Next slide, please. As shown here, the traditional 156 millimeter wafer-based modules were not much taller than the height of the average American male, which apparently is 5'9". And for semantics, just to make it easier going forward for the rest of my presentation, I'll state the wafer sizes without the units. So the transition to 158s occurred in the last couple of years, with 166 becoming commercially available not long after 158. Actually, just a year or so ago, a 166 module would have been considered quite large. Then last year, wafer and subsequent module sizes became supersized, with modules beginning to be sold that are close to 8 feet tall and 4 feet wide. And to get a visual representation of that, of course, look at the screen here, but you can also imagine, a piece of drywall or a piece of plywood. Those are typically sold in 8 feet by 4 foot sizes, which is much larger than traditional modules. Next slide, please. So the table shown here compares different aspects of the two large format sizes leading this transition. One based on M10 wafers, which are 182 millimeter wide, and one based on G12 wafers, which are 210 millimeter. We compare these to the baseline large module, which, as I said before, is based on our M6 wafers, which are 166 millimeters. This comparison uses a data set of what we consider typical specifications rather than being based on one specific module type. So you can see here that the significant increases in power come at the expense of increased size and weight. These power increases are typically attributed to increased current, which is proportional to cell size, while the voltage stays constant as it's proportional to the number of cells in the modules. You'll note, though, the decreased voltage on the 210 module is due to a lower cell count used in modules with these larger cells. Another consideration with these larger modules is the container density and subsequent transportation costs. As shown here, the highest power per container, and therefore the lowest transportation cost, comes from the 182 based modules, although manufacturers are working to optimize this, so that might change in the future. Also worth noting is which manufacturers are focused on which size as we approach this VHS versus Betamax point in the industry. So some large players like Jinko and Longi have firmly stated that 182 is best, while Trina and Risen are solely focused on the transition to 210. Other players such as Canadian Solar and JA, as shown here, are offering both sizes, seemingly deciding to pick both horses in this race. Next slide, please. So there are obvious benefits to switching to large modules. The most significant is higher power classes that are available. If you're able to keep the labor time per module maintained, then the labor cost per watt can be greatly reduced. Also, higher powered strings mean you need less balance of system components such as combiner boxes, and that offers additional savings. These and other potential financial benefits will be further detailed during Matt's presentation, following mine in a few minutes. Next slide, please. So as a test lab, we're really looking to determine what are the risks of new technology. So unfortunately, with the benefits that I just talked about, come additional risks. So in many cases, the same glass and frame thicknesses are being used on modules that are up to 55% larger. And we've seen in our testing that microcrack susceptibility increases with module size, as shown in the EL images here. This trend will likely continue for 182 and 210 based modules, especially if they're not reinforced with thicker glass or built up frames. There can also be issues with increasing module current, including the potential for hotspots due to the higher current, and just generally higher degradation rates, and junction box or perhaps diode failure. So the inner module component selection must be carefully considered to mitigate these potential risks. And finally, there's also risks based on manufacturing challenges. We've already seen glass shortages in the market causing shipping delays and increased module costs. And these larger modules could result in reduced module lamination throughput, which may also affect manufacturing timelines and cost. There have also been reports of in-factory test equipment being too small for completing routine testing and characterizations, which we feel is a significant red flag. Next slide, please. I'd also like to highlight some concerns related to site design and other equipment. So the higher currents from these modules will require larger cabling to reduce the resistive losses. These larger conductors will obviously offset some of the balance of system cost savings. So you spend less on combiner boxes because you need less of them, but all of your home run cables cost more because it's got to be a larger gauge. And as I've previously highlighted, there are significant mechanical and electrical differences between the 182s and the 210s. So if your site is designed around one size, switching to a different size in a later development stage will result in significant re-engineering costs. You need to kind of pick which one you're going to use at the start of the project and carry it through. And also related to the fungibility is the difficulties in replacing smaller modules on existing sites. As manufacturers transition to these new supersized modules, they will phase out previous generations. And it may soon be impossible to get replacement modules for sites that are operating or just coming online. While the industry stays forward-facing to achieve cost targets and increase deployment throughout the globe, module manufacturers must keep an eye on the past and have a plan for servicing warranty claims. So that's it from my side. I certainly look forward to further discussions during the Q&A. And now I'll pass it over to Matt to dig into the financials.
Thank you, Tristan. That was super interesting from my owner's perspective. So hi, everyone. My name is Matt Murphy. I am the COO of Greenbacker. We are an asset manager that owns a number of funds. Our flagship fund is called Greenbacker Renewable Energy Company. And that fund constructs, owns, and operates solar, wind, energy storage assets. We have about 950 megawatts of assets now, somewhere between construction and operation, with another gigawatt or so in our pipeline. And I think it's just important to note about the Greenbacker strategy, so you can understand my perspective of ownership, is that we are a true long-term owner. We are planning on owning these assets till they're decommissioned. We do not have a post-tax equity flip strategy and foresee the liquidation of assets from our fleet to be only when opportunistic, and for the most part, not happen. So we're in it for the long haul on all of our solar, wind, and energy storage plants. And I think that's important. And before I get into how we're looking at cost savings with these new large format modules, I'd just like to address a question that I get asked all the time, and I think it's important, which is what is approval going to look like from our institutional partners? So at Greenbacker, we have very large tax equity and debt agreements with some of the major financial institutions in the world, partners like KeyBank and Morgan Stanley and PNC and Fifth Third. And people want to know, are we going to be able to get these modules approved? And we've had conversations about this already. So our perspective on large format modules is that this technology is iterative and not disruptive. And so iterative technology, it's just a new version of something we've been doing for a long time, right? And something we've previously improved, as opposed to disruptive, which is completely rethinking something we've done with a totally new type of technology. Disruptive technology, we generally have difficulty getting approved. It takes a long time. There's a lot more work to it. Iterative technology still takes some work, but it naturally flows. For instance, changing inverters from 600 volt inverters to 1,000 volt inverters to 1,500 volt inverters. It's much less painful than actually trying to rethink what we do. And so we're not worried about it. We know we'll get there. We're already planning, already talking to institutions and getting everybody comfortable with using these large format modules. So there's the answer to that question. Next slide. So at Greenbacker, and it's very similar to Borrego, they've actually been doing this for quite a long time. We're interested in looking at the holistic costs of building our assets, right? So a lot of times, and people make this mistake over and over again, and I made it, past me has made it. But when we're looking at things like procuring modules, you're thinking of your dollars a watt. What am I paying? What am I paying? And 29 cents versus 27 cents, I saved 2 cents. I bought 100 megawatts, big savings. At Greenbacker, we're trying to think of things as the whole component of installing, right? So a module cost is not only how much did I pay for the modules, but it's also what did it cost me to put the module in? What did it cost me to install it? Down to the wiring, the home run wiring back to the combiner boxes. And in this case, when we plan this out, we see some pretty large potential savings in installation costs based on some of the things Tristan said. Less combiner boxes, less tracker material, less installation costs because there's fewer things to install. And when you look at modules in this way, and as you can see here, you're looking at that granular level at some very small savings. We're talking fractions of a penny here, but when added up can be pretty significant. As you can see in this slide, looking, if you go from 450 to a 575, potentially you could save 2 cents on your installation. So if I'm comparing a 28-cent module and a 27-cent module, and I can get a larger format at 28 cents, it might actually be cheaper overall than the 27-cent module. And these costs, of course, vary based on the technology, but we find really that with trackers, it makes the most sense. It's almost a no-brainer to pay slightly more for a large format module. But when it comes to fixed tilt systems, it can be different. And I think it's very important to note here that these are direct construction savings. So these are costs that I feel you can very much count on. Whereas there are potential other savings here by using large format modules. We could see O&M prices go down. I'm very conservative on O&M costs and the ability for O&M providers to see less equipment and sort of budget out that way and charge me that cost. But there will be other sources of savings from having less components on site that could further the savings here. Next slide. So this is just another visualization of the numbers that we just looked at. And as you can see, the tracker savings are significant, and we see less but still meaningful savings when planning for fixed tilt installations. Next slide. So this is just the same simulation run again, but for a switch from a 410 module. So the change is a little bit bigger. And again, we're seeing, again, holistic installation costs reducing. And in this case, in almost all of the examples, reducing even more. This is very interesting, right? Because right now, our installations with 450 modules are probably just being installed. But we're very familiar with 410 watt modules. We've been installing them for the last year or two. So this is a direct comparison to what we're seeing now. The projects I've done in the last 2 years, if I had done them with large format modules, I could save this much money. So it's got a practical application that I can understand. Whereas on these 450 sites we're waiting to go in, it's less practical because we haven't built them yet. We haven't seen the total costs. Next slide. So this is, again, a visualization of what we just looked at. I think one thing that's important from an owner's point of view that everybody should understand is that these savings can be potentially significant, but they come not just for free, right? This is going to be an iterative process of first working with sophisticated builders. Borrego is a good example of that, someone that can look at this kind of change and say, yeah, there is savings here, and my pricing to you to build an asset will reflect that savings. It's not going to come automatically, and with less sophisticated players, it's going to take them a while, or more conservative players, right, that aren't going to give you the cost savings till they see it. But it's going to take the industry naturally a while to manifest these savings that we just talked about. And so sophisticated owners, sophisticated builders can do the best job of leading that charge and really realizing, and frankly, taking advantage of the market before everyone else figures it out, that there are cost savings here, and this is a real thing to adopt, to lower the cost of power and accelerate the adoption of renewable energy, as Borrego likes to say. So that's it for me. Thank you very much for your time, and I will pass it to Aaron Hall to talk about EPC considerations with this new large format technology.
Thanks, Matt. Yeah, this is Aaron with Borrego. Been buying modules for about 2 decades, so this is a passion of mine, talking about modules and monetizing the value that you can unleash by choosing the right module on your project, and then choosing the right system design to go along with that module. Funny, Matt was saying 410s, oh, we know those. We've been doing that for 1 or 2 years, but it may be 1 year, but not 2 years. This has been moving quick. Not too long ago we were installing 380s, and not too long ago we were installing 360s, and et cetera. And of course, in my early days, we were installing 180s. So the pace of change has accelerated for sure in the last year, and going forward for the next 1 or 2 years. Next slide. So I'm going to give just some kind of a little random list of thoughts that you'd want to consider as a developer or an EPC when contemplating these large format modules. So I'll start with developer and go to EPC. From a developer perspective, obviously the most important element of these large format modules, and reason why you'd go there is to reduce costs, which we've been hampering on in this presentation. Matt just went over some granular details of examples of that. Multiple cents per watt reduction in your CapEx. And so therefore, obviously, if you can get a lower EPC price, you can make more for that asset as a developer if you're selling it, or if you're owning it long term, it's just going to be worth more to you. I do just have a practical bit of advice. Because of the transition we're undergoing, you might find yourself hiring an EPC, running an RFP with a 410 or a 450. And then after the fact, maybe you shortlisted, maybe even gone awarded the deal to one EPC, and then you've come across this large format module, and you put that in front of your EPC. And I'll just say, I would recommend you do that before if you can avoid it, because it will probably be harder for you to monetize all of those cost savings if you've kind of not in so much of a competitive environment that the EPC finds themselves in when asked, oh, how much does this module save you over that module? In talking to our development colleagues, the height has not really been an issue. You could say these are taller modules, and therefore, all else being equal, you're probably dealing with higher max heights on your arrays. It just hasn't been an issue yet. That said, it's always advisable to, when in the entitlement process, and dealing with the planning boards, to start with a high, max height theoretical limit, so that you don't have to, after the fact, go back to the planning board and say, actually, we need to be a foot higher, and then kind of be at their mercy, and who knows what can happen there. Usually we're moving fast in the process, and we don't want to go back and re-engage when we've already got approvals. And then, of course, if you're a developer that's going to sell the asset to a buyer in IPP, they may have issues or concerns about the size of the module or the technology, being that it's new. And so that's just blocking and tackling kind of thing, but it's become more of an issue if you're showing them a 540 than if you're showing them another 410. From an EPC perspective, racking is a big one. Understanding the compatibility of that rack with the module in question. The fixed tilt systems we found to be widely compatible. We haven't had an issue. Once in a while you might run into we could have used a 5x4, but now we got to do a 5x3, or that's not the right example, but something like that. That seemingly may be a step back in your cost reduction efforts, but it may not be, depending on how many watts you're still having per foundation and per table, et cetera. But fixed tilt generally has been very, very friendly and accommodating, and you see the benefits, and tracker as well. But in some cases on tracker, you will run into a case where you need a longer clamp that could add costs. And you know, high wind, high snow load areas may have more of the array subject to that condition than other areas, and therefore a bigger impact. But that also varies based on tracker manufacturers. Some don't have that issue at all. One of the big two doesn't, and one of the big two does. So it just depends. And then, of course, keep in mind the timing of getting a UL 2703. We usually require samples to be tested by the manufacturer. It's a pretty fast process, so it's not a big deal, and you can usually do it later in the game, but just something to keep in mind for coordination purposes. And on rooftop, I would say that's where we're not ready. Some of the leading rooftop manufacturer vendors, racking vendors, are not in a place today where they can even price out their rack, let alone provide you like a set of structural engineering plans for you to get a permit with. So caution for now on rooftop, if that's where your head was at. Maybe wait a few months, or maybe a couple quarters. On the inverter side and optimizer side, that is something to think about, particularly on the optimizer like SolarEdge and Tigos. They are not there yet either in prime time in terms of their ability to accommodate the higher short circuit currents, you know, over 11 amps. And so they're on the roadmap. They will be here in 2022, if not earlier, but it might be difficult to get a price and a design and a spec sheet, you know, today for those products with the higher format modules, 500 watt plus. And then on string inverters, we're generally fine, but you may have to kind of back out a module from your ideal string length depending on the circumstances. And lastly, logistics costs. Tristan showed an interesting inflection point where I haven't really personally looked too much at the 210, you know, 600, 650 module, but definitely going from the 410, 450 to 540, let's say, there is a trend that the logistics costs are reducing. Once again, it might come back down when you get to the next size, unless they optimize their packaging. But for now, you do see more watts per pallet stored. So your storage costs will go down if you're storing modules. Your shipping costs should go down because there's more watts per container. And by the way, that's a hot ticket item you might have heard of recently, shipping going nuts. And some trend of maybe some vendors wanting to do FOB deals versus DDP deals. And then obviously less pallets to handle and distribute in the field. Next slide. So just wanted to give you a perspective on where we think things are going and where we sit in the process of that evolution as a company. So Borrego development, we're all in. And know what that means is when we entitle projects today and go to planning boards and whatnot, that includes these 180 millimeter modules. So we're already transitioning our development fleet and our assets to that going forward. And even in cases where we permitted an older module, we're often changing that to a newer, larger format module. Why? Because we want to maximize our dev fee on these assets, and we think that's going to get us there. As an EPC, we're also pretty much all in. Sometimes we're taking modules that are provided by owners that they bought for safe harbor or whatnot. But when we have influence over the module decision, like Matt alluded to, we can show an owner, okay, we can do it that way with your 410 or your 450, but we can do it this way with our 540. And by the way, you know, look, our EPC price went down by 3-4 cents a watt, and your yield went up in some cases. And so, you know, your owner are much better off with this solution. And then I'll just say a quick case study to put some numbers on this. We had an example in Washington where we were awarded as an EPC 3 projects, trackers, 7 megawatts apiece. The owner was going to secure 29.5 cent 450s. We said there's a better way to skin this cat. Let's explore these 34.5 cent 545s. And long story short is we demonstrated about a 5-cent pickup on CapEx and over a 1% pickup on yield as a result of transitioning. And so we were able to more than cover the delta in the modules, and it was all around an improvement. Next slide, please. And I think I just want to end here with just a tactical point. Borrego has been looking at module trends for a while. We're always got our finger on the pulse, and we recognize these high watt modules and the value that they carried a good 6 months ago. And we also juxtapose that with the supply availability of these modules, knowing that 2021 was the year they would show up on the scene, but in limited supply. And you may have already discovered that you probably can't get your hands on a 540 before November or December if you can get your hands on one at all. And if you can, it's expensive, like most modules right now. The prices have been going up because of various reasons I've alluded to earlier in the discussion. So just my point here is that we went long. We bought a bunch of these modules, over 100 megawatts, so that we could come to the conversation with owners with ability to add value and differentiate ourselves a bit. And so I just wanted to point that out to all of the audience. If you are looking, if you're swayed and you're looking to improve the value of your projects and you want access to these modules, but you don't have access, or you'd like to see if you can get a better deal, etc., I encourage you to contact me. And we've got a form you can fill out online that I can send you. Just send me an email, aaron@borregosolar.com, and we'll send you that form, and then we can engage with you and send you a quote and show you your options. And even go further. And I'll just make the point, we do not even have to be associated as the EPC on your project. We can just provide you support on the module procurement side. I think that was it for me until questions.
Great, Aaron, thank you. And thank Matt and Tristan for your contribution to this presentation. We're now heading towards the end with the final poll question. So we want to know if your mind has changed on the size of module you're considering based on the information that was presented here. So if you don't mind filling that out, we greatly appreciate it. We'll sum those up and show them as we're now moving into the question and answer section here. Next slide. So we have a bunch of questions coming in. There's one here that says, are there any OSHA concerns once you get to the 210 meter size modules? And maybe Tristan, start with you and then see if Aaron or Matt have anything to add.
Yeah, I haven't looked too deeply into this. I think it's still considered like a two-person lift. It doesn't exceed that amount. But I'm not as concerned with that was more researching in the lab to make sure that 2 of our technicians can lift them into chambers and such.
Okay.
Yeah, I actually looked this up right before the presentation, so it does seem to still be a 2-person lift. And I think EPC wise and our installation wise and protecting our equipment, I'm actually more concerned with the care and concern taken with moving a module that large than I am with the weight. Especially with what Tristan said about frame and glass thickness being the same, but over a greater area. So I don't think there's a safety concern, but I am concerned about the diligence and care people take in handling the modules.
Okay.
Yeah, I mean, we see normal modules getting mishandled
all the time.
So adding 55% more weight and more size seems risky.
Okay. Well, I mean, on that thread of weight and size, there's a handful of questions here around the cost of installing these panels based on those 2 attributes. I think we touched upon it a little bit, but can you shed a little more light on some commentary around the labor cost for the installation of these size panels?
I mean, I think the main takeaway from on that topic for me is is that it's become a two-man job already. Before we get into the 500 watt plus, I think maybe even at 410, frankly, a lot of people are using two people to move the modules around. You may have more, and particularly on utility scale jobs, maybe have more equipment coming into the picture during installation. But I think mostly we're still talking about people moving them around, and so it's not a difference. Yeah, you can have some more fatigue potentially with higher weight, and that might play a role. But largely, I think the way we're modeling things, anyways, is that it's, you know, 2 people per module. Before it's 2 people per module. Now a similar kind of productivity rate, but more watts per minute spent moving modules around and per man hour. So I think overall it's definitely our perception that there is a cost reduction on the labor side. And then of course, the most tangible element is on the actual racking side and electrical BOS side.
Okay.
Yeah, I would just say based on the numbers that we looked at, the actual savings in installation, it was like a small fraction of this total savings that we looked at. We do anticipate that maybe at the beginning that people might be seeing more labor going a little bit slower, but that eventually, Aaron is right. As soon as people get used to the new technology, the production rates are going to be about the same. And the question is not that concerning, just because if you're talking about, I could save 4.8 cents, it was like what? A fraction of a penny of that was actually savings on the installation. So if we missed there, it is not enough to move the needle to make us decide that we wouldn't want to install large format modules.
I think that's a good comment, Matt. I think largely, frankly, when we kind of dove into the numbers initially as a company in our products group, we spent time looking at technical and commercial diligence of these modules, the savings were large. And so we knew like the categories may not all be perfect and they may not apply to every you know, bespoke installation and technology and racking type, but they were meaningful, such that it didn't matter if we got all of the details right. It was the directionally seemingly the right move to make, with of course all of the caution that Tristan brings to the table. Not all modules are made equal. One way that we are made more comfortable getting early in adoption of these modules, where like I can't say I've installed them before, but we're going long on them. And that is by, frankly, depending on PVAL's PQP program and going with vendors that have been a leader in the PQP, product qualification program, because that says, okay, these guys are careful. They're careful about their selection of their BOM. They think about the things like dynamic mechanical loading and you know, damp heat testing and stuff like that. And so for now, to be fully transparent, none of these guys have put their 540s through you know, Tristan's program yet. That's all happening, you know, kind of quote unquote as we speak, next 6 months. But just having the right company that has gone through it multiple times before suggests that they're going to do it again and be conscious of it and make changes if frankly they don't get the good results that they're hoping for.
What about the impacts of row spacing and inter-row shading based on the size of these panels?
I mean, you're all else being equal, going to have more, you know, more space between your row if you want to have the same kind of shade profile or specific yield kind of result. But also something that happens in DG anyways, that you can find is with the bigger module, you actually have, it's, you know, if you get to utility scale, forget this comment, but for some smaller jobs, you may actually have with the bigger, well, it could work both ways, but some cases, the bigger module, you're gonna have less rows, less inter rows, you know, less rows, less space between the rows, less rows, I guess, because each row is more watts. And so you have less of them, and therefore less space between the rows. So it could help your kind of ground coverage ratio and from that perspective.
Okay. We have some, let's see here, a question on mono versus bifacial panels. Are these larger ones one or the other or both?
We've seen both for which types of modules get submitted to PQP testing. But typically when we see the monofacial, they've already engaged with us for their bifacial testing. We rarely see manufacturers just test the monofacial version, where in the past, a couple of years ago, it was always monofacial, and if they wanted to add a bifacial design, they would do so. Now that has flipped, and I think that the market has really, that shows that people like Aaron are demanding data on the bifacial modules more so than on monofacial.
I can add that, well, first of all, yeah, everyone's got both. Nobody's like, oh, I just have a monofacial 540. I haven't run into that yet. And also, I believe part of the reason is that most of the manufacturers have started using bifacial cells, period, even in the monofacial module. And so the question is just, what do I do with my back sheet? And is it transparent back sheet or glass or a white back sheet? And then that also impacts like EVA considerations and things. But they're kind of already using that cell as far as I understand, and so it's a pretty easy transition. And when we were initially talking, a year ago, you'd hear things like 4 cents difference between a bifacial and a monofacial, and now you hear much lower difference between the two numbers, two technologies. Such that Borrego, anyways, we've kind of said bifacial, and we're not looking back. Doesn't make sense not to do it. Maybe on a rooftop, it's not quite as obvious, but generally speaking, that's what we're seeing.
Okay. Tristan, we got a question for you. When do you expect the testing to be completed and the data to be available for us?
Yeah, I see that question. I like Tom's use of another TLA 3-letter acronym. I looked and saw LFMs. What's an LFM? Oh, it's a large format module. So
yeah, got a new acronym to add.
Just another acronym to add to. So we have over a dozen different module types, whether they're 182 or 210s, in the lab now, in the chambers now. They're going through, we already have, witness reports available, intake reports. I believe we have light soaking reports. We're not far away from having pan reports, which show the module performance at different irradiances and different temperatures. And then the interim reliability reports are not far to follow. The first ones should be released in the next month or two, and then final reports a couple months after that for the full duration of thermal cycling 600, damp heat 2000, like the extended IEC tests that make up some of the reliability portion of the product qualification program. So there's data available now, and the full suite of data will be available by the end of this quarter, I would imagine.
Tristan, is there anything you can't test? Like, oh, our chamber isn't physically big enough, or have you gone over all the issues there?
No, there are modules that are too big. Someone is sent me a data sheet of a 78 cell based on a 182 millimeter module rather than a traditional 72 cell, and really these are half cut cells, but anyway, it would be I think a 156, and that won't even make it into the chamber if we bent it in half. It's just, these things are enormous. So yeah, I think for the most of the call it standard product sizes of 182 and 210, those will fit. And I should mention that there does seem some encouraging signs that there will be standard sizes of 182 and 210. I've seen the same dimensions used on multiple different manufacturers' data sheets, whereas before with the 158s or the 156s, they're a couple millimeters wider or a couple millimeters shorter. They were all slightly different. Even though we've got two camps of 182 and 210, I'm hoping that there's some standardization around the module sizing, and you can swap out different manufacturers modules without having to change the design because it's a couple millimeters too wide, if you will. So that's encouraging.
Definitely. We have some more technical questions on the maximum efficiency of these large panels and the materials that are used.
Yeah, I saw that question come in, and I did a little research while my co-presenters were up. So it's like the main gains here are from the size of the module, not from the efficiency. So looking at, sort of the Trinas, the Longis, the Jinkos, looking at their data sheets for their 158 products, they were around, high 19s, low 20s for their efficiency. And now looking at their 182s or 210 data sheets, they're at high 20s, low 21s for their efficiencies, which, it's an improvement in efficiency, but it doesn't justify going from like a 390 up to a 550. So most of the gain is from module size, not from modules becoming more efficient. The module efficiency creeps out each year with incremental improvements, so that's definitely reflected here. But this large jump, as Aaron was saying, they were doing 390s not too long ago, and then 410s, and now 450s, and out of nowhere 550s. That is not an improvement based on these incremental efficiencies. It's because the modules are, as I said, 55% larger in some cases.
I will, though, push back a little bit. I mean, you said it, so I'm not pushing back. I'm just, I guess, diving into part of what you said, which is that they are a little higher on average. Maybe that's just because of natural evolution or what have you of their processes and whatnot. But like you said, I'm used to seeing, I'm looking at like a chart here of like 450s in the 20.3, 20.4% range. And you can also see a 525 in that same range. So there are examples like that, but then when you get into the 540s and 545s, you're up at 21%. And that is relatively new territory. I mean, SunPower has been there before, for example, or LG maybe here and there, even them actually not that much. But so while it's not the answer, they didn't go way more efficient, and that's why they're 500 watts.
Yeah,
correct. They are directionally better, or there are examples where it is better as you bump up to the 540 plus watt class. And for us, that is a big deal. Going from 20.7 to 21, we're trying to, as an EPC, trying to prove our value to owners, and therefore we're trying to show them how they can increase the value of their assets, and going up on efficiency can help a little bit on cost, and usually more importantly on revenue side. So we do notice it, but you're right, it's not consistent. It doesn't, and it's not the answer of why they got bigger.
And I don't want to downplay the gains. Every 0.1% efficiency gain should be applauded by the entire industry. That's the direction we need to go. And there are, you can see going from 3-busbar to 4-busbar to now 11 or 12 or 10-busbar in these new modules. That will impact efficiency. Manufacturers are also looking to remove the space between the cells to tiling ribbon or seamless soldering or gapless technology. They all have a different way of calling their solutions, where they're removing that gap. That's going to also affect module efficiency. It doesn't affect the cell efficiency, but now there's less space on the white space on the panel, or open space. So that's all great. It just doesn't, it's not what the main driver to get us to these much higher wattages.
Okay. Well, in respect to end on time, Tristan, Matt, Aaron, appreciate all the work you put into this and the time today and the insights answering these questions. and everybody on the webinar. I know you have super busy days. Thank you for carving out this 50 minutes to join us here. As we mentioned, we will follow up with the video recording. We also have a dozen or so questions that we didn't get to. We'll make sure we answer those and circulate them back to the attendees. And the poll questions that I promised, it's just going to be in a follow-up email. We ran out of time. We were really deep into these questions and answer section, which was very insightful. So we'll make sure that we also include that in the follow-up package. So thank you, everyone. Have a great day.
Thank you.
Thanks, everyone. Bye-bye.
Bye-bye.